Welcome to another video. In this video, I'm going to discuss about the nature of the roots. As I have already said in earlier videos that the nature of the roots will depend on the value of the discriminant. And this discriminant is equals to d equals to b squared minus 4ac. And this is taken from the formula which gives the value of the roots here. Okay. So based on this value, whether it is greater than 0, which is positive, or equals to 0 or less than 0, it will decide the nature of the roots. Here the nature of the roots means that the roots can be real and equal, real and unique, which means two roots will be different, complex. It means that it will contain this complex number which in the form a plus bi, which is I is the imaginary number and a is the real part. So this kind of thing is called complex, as well as the roots can be purely imaginary. Okay, so these are the nature of the roots that I was talking about. Okay, now let's go to the first condition. The first condition says that discriminant d is greater than 0, which means that this will only happen if the b squared term is greater than 0. Even if b equals to 0, this 4ac should be positive, okay, such that it will give the positive value, okay, not the imaginary. Now let's see example here. Here to find the roots, we have to set this to 0, right? So we'll get x squared minus 3x plus 2 equals to 0. And here a equals to 1, b equals to negative 3, and c equals to 2, okay? Therefore, finding the roots alpha, beta, we get negative of negative 3 plus or minus negative 3 whole squared minus 4 1 times 2 divided by 2, okay? So here we will get 3 plus or minus, here is 9 minus 8 is 1, so root of 1 is 1 upon 2. So alpha is just 4 by 2, which is 2, and beta is 3 minus 1 is 2 upon 2 is 1. Here we got alpha 2 and beta 1. So both are real, right? And these are not equal, which means this alpha and beta are not equal, right? But they are unique and it is real, okay? Even if this b equals to 0, this part should be positive such that plus or minus root of 4ac negative upon 2a, right? This one should be positive to give the value real, okay? Therefore, if d is greater than 0, the roots will be real and unique, okay? Now, in second case, d equals to 0. This will only happen if b squared equals to 4ac. And if this is the case, then our root of d will be 0, right? Therefore, roots will be negative b by 2a. So to understand more, let's see this example here. We have 2x squared plus 4x plus 2 equals to 0. We have to set this to find the intercepts. So our a value is 2, b value is 4, and c value is 2, okay? So finding the roots alpha comma beta, we get negative 4 plus or minus 4 squared is 16 minus 4, 2, a value is 2, c value is 2, and we have a value is 2. So we get here negative 4 plus or minus 2 is 4, 4 times 4 is 16, so 16 minus 16 is 0 over 2 over 2. So we have negative 4 upon 4, so we have negative 1. So here alpha equals to negative 1, beta equals to negative 1. But here this alpha and beta are equal, as well as they are also real. So if d equals to 0, then alpha and beta will be equal, as well as they will be real. Okay, so this is what this condition number 2 says. In condition number 3, it says that if d is less than 0, so this will happen if b squared is less than 4ac and b squared is not equals to 0, if b squared is not equals to 0. So here the alpha and beta will be in this form, right? So if this is the case, then the roots are complex, which means it will have real part and the imaginary part. Let's see for this equation. We have that 2x plus 3 equals to 0 and a equals to 1, b equals to negative 2 and c equals to 3. So finding alpha beta, we get negative of negative 2 plus or minus negative 2 squared is 4 minus 4, 3 c3, a value is 1 and a value is 1. So we will get alpha beta as 2 plus or minus, here 4 3 is 12, right? And 4 minus of 12, which means it is 8, so which will be negative 8 like this upon 2. So I can write this as 2 plus or minus this one. Here I can write this as I of root of 8, right, upon 2. And I can also write plus or minus 2i root of 3 upon 2. So my alpha will be here 2 divided by 2 plus 2i root 3 upon 2, and my beta will be 2 minus 2i root 3 upon 2. So alpha will be 1 plus I root 3 and my beta will be 1 minus I root 3. So you can see that these roots are complex, right? And this is actually conjugate. Therefore, if d is less than 0 and b is not equals to 0, okay, which means that 4ac is greater than b squared. So if this is the case, the roots will be complex. Here complex means it has a real part and a complex part. So this is how the root will behave. So when b equals to 0, what will happen is the root will be plus or minus c by a, right? So here let's see for this. We have x squared plus 3 equals to 0, and here b equals to 0, a equals to 1 and c equals to 3. So our roots will be alpha beta will be here negative b plus or minus, so b will be 0. So what I will write is plus or minus directly root of b squared minus 4ac upon 2a. So I will have negative 4ac upon 2a, right? So here a value is 1, negative 4, a value is 1 and c value is 3 root upon 2, right? So 2 minus 2, so it will have negative 12. So I can write I root of 12. Okay, so it will be divided by 2, so it can be 4i root of 3 upon 2, and it will be plus or minus 2i root of 3. So if you see very carefully, this alpha and beta are purely imaginary, which means our real part is 0, right? So this is the case when b equals to 0, but this b squared minus 4ac, this discriminant is less than 0. So the roots will be completely imaginary.